All right, so on Canvas, we are going to be opening up the Gravity in Orbits Simulator and the Gravity in Orbits Lab. So there's two links. It's under the Lab Activities tab. The simulator is a website, PHET. It's an interactive simulation. And what you're going to do is you're going to basically hit the little play button. So if you could please do this as I do this. And we want the model version, which means it's not going to be to scale. It's hard to make these interactive things to scale. Okay. And this is what it looks like. Now, I'm going to go back to Canvas. And I'm going to open up the file. It's called Gravity in Orbits Lab. You're going to click Get the Template. It's going to make a copy for you. And what you're going to do is you're going to put your name up here. And also, please get rid of this copy of and the title. And you can put your name up there as well. Let's see. Okay. So this is the lab packet that you're going to be using. Again, ultimately, in the end, you're going to take an open note quiz. So you're going to use this document, and then you're going to have quizzes in a different tab, and it's going to be a quizzes quiz without the timer on. Okay. So right here, our objective is to use this computer simulation of the Sun, Earth, Moon orbit to see how the different variables affect the orbit and the force of gravity between two objects. Ultimately, and in the end, you're going to really see how mass and distance truly affect the gravitational force in a solar system. Okay. Meaning, is it going to keep the planets in orbit? Are they going to fly off into space? Are they going to crash into the sun? That kind of thing. All right. So the part one here kind of tells you how to set up your online simulator, the PHET website. So you're going to choose model. We already did that. You're going to select Sun and Earth only, which is what it naturally does. It's the very top. Okay. So I'm going to go back to here. Everybody have this open? Okay. So the one that naturally comes up is the Sun, Earth, Moon. I'm sorry, it's the Sun, Earth, and that's it. Okay. What you're going to do is you're going to check all four of these boxes. The gravity force, so the blue arrows are representing the force of gravity between the two objects. The longer the arrows, the stronger the force. If they were smaller, there would be a weaker force. Okay. The velocity is going to show you the direction the planet wants to go in. Remember, all objects travel in a straight line unless acted on by a force. So that's the direction that the planet is trying to go. But of course, gravity is going to pull it in, keep it in orbit. The path is going to literally trace the path when we play this in motion. And the grid is helpful for later on. It's just kind of like a reference point. Okay. You see then there are these toggle switches down here. So the standard is that, like this, the mass of the star, this is what it normally is. And you're going to be able to change. You can kind of see how the sun is changing size as I go back and forth to different sizes of the sun. Same with the size of Earth. The planet is our Earth. You can go up to twice the size or half the size. Okay, I'm going to keep them at standard size for now. Alrighty. Down here is how you play your animation. There's a play button. This is going to tell you how many Earth days are passing once it's animating, once it's going. This is a reset button and refreshes everything. Okay, I'm going to hit play. This is our normal mode. The sun is the current mass and the Earth is the current mass. And I'm going to hit play. And what it's doing is it's orbiting, okay? And it's telling you how many Earth days are passing. You can see the gravity arrows keeping that planet in orbit, even though it wants to go the direction that the red arrow is pointing, okay? And you can kind of see, and you can fast forward it if you're impatient, all right? But you can kind of see how we are, like I'm stopping it there. I just stopped it right past the year mark. So a year is the amount of time it takes to go around once around the sun. It's 365 days. So I stopped it a little bit later than that. Notice this elliptical orbit. It's not to scale, but look. We have 1, 2. The Earth is 2 blocks away on this side, but it's like not quite to on the other side. Does that make sense to everybody? So it's not like the sun is not in the dead center of our orbit. And that's what elliptical means, this elliptical orbit that we have. Okay. So highly recommend every time you do something new on the document, you hit this reset button up here. This resets everything, the orange reset, and then you got to click all the arrows again, the check marks. That you want to reset. And it still keeps all of these like things checked right here. So what are you going to be doing? You are going to be investigating different sizes of the mass of the sun. So the regular size is what I just did. Here's 0.5 sun, so you're going to shrink it down to half. You're going to do that little toggle bar. 1.52, you're going to describe the force of gravity. Remember, the force of gravity is the length of the blue arrow. So if the arrow gets longer, you can say gravity is increased. If the arrow gets smaller, you can say gravity decreased, okay, or less gravity. And then you're going to describe the Earth's orbit. What happens? Does it orbit? Does it fly off into space? Does it crash into the sun? Okay. Then you're going to be investigating the distance, the relative force of gravity. That's where you need the grid marks, little blocks in the background, because you're going to actually move the planet a certain distance away from the sun. 1 block out or 1 square, 2 squares, 3, 4, etc. The standard is 2. So this is what you got to do for that. Okay. You have to minimize, you have to shrink it down. You have to zoom out. Okay, because this is the standard, is 2 blocks away from the sun. So you literally, for that part 2 there, you're going to pull the Earth 1 block closer. Try to keep it on the grid mark. You want to keep it all on this, like, this line right here that cuts the sun this way. And then you're going to play that out. And then you're going to do 3 blocks away from the sun. Then you're going to do 4 blocks away from the sun. So you're going to basically change these manipulated variables. Everything else stays the same. You only change one thing at a time, right? That's what an independent variable is. So like part 1 on the worksheet is experimenting with the different masses of the sun. Where'd I go? Mass of the sun. The next part is experimenting with distance, data table 2. How far away and how that affects the gravity. Okay, so those are the 2 main things there. One of the first things you have to do on part 1, again, is just play by. We just did that. Like question number 1 under part 1, describe the shape of Earth's orbit. That was like the normal mode. How long does it take to orbit 1 time around the sun? Like how many days? And the last thing actually has you turn off the force of gravity. And that is rate. I'm going to reset. Always reset every time you do something new, because you want to make sure everything else is the same and you're only changing one thing. That's right here. You turn your gravity off for that one part, and then you hit play and you see what happens. If there was no gravity in the solar system, I think you can pretty much figure out what's going on there. The only time you do that is for that question only. Everything else, the gravity obviously has to be on. Okay? So that's basically it. Let me know if you have any questions, and I can help you out as best as I can.